Okay, these are day 2 notes over graphing log functions, so we're getting a little more in depth here. I have the logarithm y equals log base 3 of x plus 2. And what's important to note here is that the x plus 2 is in parentheses. So I don't have anything to do here other than to put it in exponential form because I don't have anything to move around or anything to do. So I am going to put this in exponential form. So my base is 3. It's being raised to the y power, and that equals x plus 2. Okay, my next step, because I'm going to be plugging in y values to solve for x, I need to get x alone. I need to get this equation in x equals form. So I'm going to subtract 2. So my equation is x equals 3 to the y power minus 2. So here, now I'm going to jump straight into graphing like we did the day before. So I'm going to be plugging in y values to crank out my x values, which again is super weird to think about, plugging in y to get x, but with logarithms you have to approach it backwards. So let's start off with a really basic y value to plug in. Let's plug in 0. And this one you're going to have to be a little more careful with your order of operations. So if I plug in 0, I'm going to be doing 3 to the 0 power, which is 1, but then I have to do 1 minus 2 to get negative 1. So I have a point at negative 1, 0. Okay, now let's plug in positive 1. So 3 to the positive first power is 3, minus 2 is 1. So I have a point at 1, 1. Okay, next step, I'm going to plug in 2. So 3 to the second power is 9, and then 9 minus 2 is 7. So I have a point at 7, 2. I'm going to plug in a negative now. So I'm going to plug in negative 1. So when I do 3 to the negative first power, I get 1/3, and then 1/3 minus 2 is negative 1 and 2/3. See about right there. I'm going to plug in negative 2. So I've got 3 to the negative second power is 1/9. And then 1/9 minus 2 is negative 1 and 8/9. So I'm getting closer to negative 2, but I'm not quite there yet. Plugging in negative 3. 3 to the negative third power is 1/27. And 1/27 minus 2 is negative 1 and 26/27. So I'm getting as close to negative 2 as possible without touching it. So this is about what my graph will look like. So my domain here, I'm getting as close to negative 2 as possible without crossing it. So I'm going to do an open parenthesis, negative 2 to positive infinity, since it's going on forever to the right. And then my range, I'm going from negative infinity to positive infinity, since there is no restrictions to how far down or how far up we go. Now, if you'll pay attention, your domain has been affected by this negative 2 that's been tacked on to the end of your equation. So whatever number is at the end typically is what is going to move your equation left or right. Your graph will be moved. My next example, I have y equals log base 1/4 of x minus 4. Now, this one's a little different in the fact that the x minus 4 isn't in parentheses. So that x and that 4 can be separated. And I'm going to do that first because I need to get my logarithm all by itself before I can graph. So I'm going to add 4 to each side. So now I'm dealing with y plus 4 equals log base 1/4 of x. And now I can put this in exponential form. So my base is 1/4. I'm being raised to the y plus 4 power, and that equals x. And this is going to be my equation that I'm going to be plugging everything into. So I need to be extremely careful about which y values I'm plugging in, because whatever I plug in for y, I'm going to be adding 4 to, and then that's going to end up being my exponent. So I'm not going to be super willy-nilly with what I'm plugging in for y. So a good idea to start is I like for my exponent to be 0. So I'm going to plug in -4 for y. Because I'm going to do -4 plus 4, which will give me 0. And then 1/4 to the 0 power is 1. So I have the point 1, -4. Okay. Another good number would be -3. When I plug in -3, I'm doing -3 plus 4, which is 1. And 1/4 to the first power is 1/4. So I've got a point 1/4, -3. So about there. If I plug in -2, I'll be doing -2 plus 4, which is +2. And 1/4 to the second power is 1/16. So I've got the point 1/16, -2. So I'm going to be getting closer and closer and closer to 0 the bigger the y values I plug in. So if I plug in -1, -1 plus 4 is 3. And then 1/4 to the third power is 1/64. So that's really close to 0. So I'm going to plug in a smaller y value. So let's plug in -5. If I do -5 plus 4, that's -1. And 1/4 to the negative first power is a +4. It's just going to flip my fraction. So I have a point at 4, -5. Okay, if I plug in -6, -6 plus 4 is -2. And 1/4 to the negative second power is +16. So that's 16, -6. So that's going to be way off my graph, like probably somewhere over here. So this, oh, let me fix this. That was really, really bad. It's kind of hard to graph on these. I'm going to be as close to the y-axis as possible without crossing it. And I know I didn't do a great job with that, but you get the idea. So that is about what our graph should look like. Looking at our domain is we're close to 0 as possible, so it's going to be an open parentheses 0 to forever to the right, so to positive infinity. And then our range, we're going on and on forever, up and down. So -infinity to positive infinity. So this one actually was moved down 4 units. Okay, so typically we have, let's see here. I typically have a point at 1, 0. But this time I have a point at 1, -4. So it was moved down 4. So whatever is happening in the exponent, if you'll take the opposite of it, that's going to be your up-down shift. Okay, so it's moving as down 4 units. Okay, and one more example. I'm going to be graphing y equals log base 3 of x minus 4 plus 2. So this is putting everything together. Now first we need to get our logarithm alone. So I'm going to subtract 2. So I have y minus 2 equals log base 3 of x minus 4. Now my log's alone, so I can put this in exponential form. So I have 3 raised to the y minus 2 power, and that equals x minus 4. And now I need to get x alone because I'm going to be solving for x. So I'm going to add 4 to each side. So my equation that I'm going to be plugging my y values into is x equals 3 to the y minus 2 power plus 4. Oh my gosh, if my pen will write. There we go. That's a 4. All right, so I'm going to make my table. So x, y, x, y. And a really smart place to start is with positive 2. Because whatever I plug in for y, I'm going to be subtracting 2 from. So if I plug in a positive 2, 2 minus 2 is 0. 3 to the 0 power is 1, and then 1 plus 4 is 5. So I have a point at 5, 2. 1, 2. And if you're wondering how I know what to do, I'm using order of operations. Okay, another good number to plug in is 3. So 3 minus 2 is 1. Then I'm going to do 3 to the first power, which is 3, and then 3 plus 4 gives me 7. So I have 7, 3. If I plug in 4, I'm doing 4 minus 2, which is 2. 3 to the second power is 9, and then 9 plus 4 is 13. So I'm off the graph a little bit at 13, 4, so I'm about right over here. So I'm going to go smaller. I'm going to plug in positive 1 for y. So 1 minus 2 is negative 1. I'm going to do 3 to the negative first power, which is 1/3, and then plus 4 is just 4 and 1/3. So I've got 4 and 1/3, 1. Okay, plugging in 0. 0 minus 2 is negative 2. 3 to the negative second power is 1/9. And then plus 4 is 4 and 1/9. So 4, 1/9, 0. If I keep going, I'm going to be getting as close to 4 as possible without touching it. So like if I plug in negative 1 minus 2 is negative 3. 3 to the negative third power is 1/27th, and 1/27th plus 4 is 4 and 1/27th. So I'm going to be getting as close to 4 as possible without crossing it. So this is imagine I was really, really close to 4 without crossing over that. Okay, so there's about what my graph looks like. Excuse my graphing skills, though. I'm not very good. So my domain is I'm getting as close to 4 as possible. So I'm going to do an open parenthesis 4 to forever to the right, so to positive infinity. And then my range, I'm going forever and ever up and down, so negative infinity to positive infinity. And that is it for graphing logarithms.